Hello students, in this lecture you are going to learn about genetic algorithms. Okay, so before learning about the genetic algorithms, we will understand what are traditional algorithms. So how we have evolved from traditional to the genetic algorithms. So the traditional algorithms will follow some defined steps to solve a problem. These steps are predetermined and executed in the linear or structured manner. So we have deterministic output. You'll have the structure that is a specific sequence of operations. They are often optimized and optimized for time and space complexity. So the main characteristics of the traditional algorithms are deterministic, structured, efficient. Okay, and the basic examples for these algorithms are like quicksort, merge sort. If you compare these two sorting techniques, quicksort will have the low complexity, binary search, graph algorithms like the extra algorithm, all those things. All these examples comes under traditional algorithms, what we have learned. Now, what are genetic algorithms? Okay, so what are the features of the genetic algorithms? So these are the subset of evolutionary algorithms, and these are inspired from the process of natural selection. And our normal traditional algorithms are deterministic, whereas these are stochastic, and these are based on population, these are evolutionary. Okay. So what is meant by stochastic? There we don't have the perfect input or perfect output, or like we cannot predict before itself. So it will involve more randomness and will use the probabilistic transitions. Okay. So second one is population based. They will work on population of potential solutions rather than a single. So for any algorithm, we don't get a single output. You'll get multiple outputs. That is called as population based. And the operations like we'll use the crossover selection. Okay, crossover is combination, recombination, mutation means which will change the solution according to some criteria. So examples of genetic algorithms are like DSP, traveling salesman problem, machine learning task, evolving neural networks. So all this will be optimized in case of genetic algorithms. So what are the basic differences? First one is determinism. Traditional algorithms are deterministic, whereas genetic algorithms are stochastic. Okay. Second is approach. Traditional algorithms will follow the step of sequence of steps which are all predefined. While it will change in the genetic algorithms, we won't use the predefined step. We may add or we may remove some steps. Coming to the solution type, traditional will give the exact solution, but genetic algorithms will give some group of solutions from which you have to identify. Traditional algorithms are more efficient for well-defined problems, but genetic algorithms are efficient for complex multidimensional search space where traditional algorithms will struggle. Okay, so these are the basic differences. Now, what is meant by search space? So whenever you're talking about genetic algorithms, it will set off possible solutions where I can find the solution, up to what extent I can find the solution, where this particular space is exactly optimal for my problem. So this is called as search space. Okay, if I take for representation, first one is representation, how you're going to represent this data. That is binary string means it will have zeros and ones. Real valued vectors means all vectors will be there of real numbers. Permutation means you will take the permutation of set of elements. So you can go for the permutational and combinatorial problems. Second one is fitness landscape. So first one is search space. In the search space, first one is representation. Second one is fitness landscape, where we will have some endpoint, that is boundary values. Okay, peak and valleys. If you see here, peak and valleys. Peaks means highest, high fitness you'll have, valleys means low fitness. Ruggedness, it will have the many peak and valleys, making the search more challenging. Okay, so smoothness means it will not have more rugged values, only you will have the easy and smooth values. Now, third one is your population, diversity and convergence. So when we are talking about population, if I go for binary search, in the traditional way, I'll get only one optimal solution, I'll use that. But if the same binary search, I'll work with the genetic algorithms, it will not give one solution, it will give multiple solutions. So how to explore the search space according to the solution? Diversity means maintaining diversity like different search spaces. Convergence, as the algorithm is progressing, what I'll do, I'll converge towards the high fitness. I'll move only with the high fitness in the search space and avoid the low fitness. Okay. So I will only work with the peak values rather than low values. Okay. Now, so these are the algorithms. Search space is representation, fitness landscape, population. Now we are going to the genetic operators. What are the different operators we are going to use? Selection, crossover, mutation. So selection means you have to choose the next element based on their fitness. Okay. I'll tell you one example. If you are going for any training, or you're going for SI or any police selection, how will they will check their fitness, body fitness? Like that, selection will choose the input values which are exactly fit for that particular algorithm. Okay, so that is the fitness in the selection space. Crossover, it will combine two or more solutions in order to create a new solution. So it is only recombination. Mutation, what it will do? Already existing one is there. It will add some more things or it will generate a new solution from the existing one. So that is mutation. So it will change the solution in order to maintain the diversity and avoid local optimum. So diversity is main in this mutation. Now, exploration versus exploitation. So, balancing exploration, that is, while searching for the new areas in the search space, you have to check the exploitation also, whether you are giving the good solutions or not. Okay, so exploration ensures that algorithm does not stuck in local optima, so it will go for the diverse solutions, and exploitation will improve in existing the good solutions to find the best possible solution. For example, I'm exploring a new kind of data, but that particular data should not exploit our focus. Okay, so exploration means it will stuck in the local optima and it will exploitation will increase the good solutions or improve the existing good solutions. Now we'll take one simple example, traveling salesman problem. We are familiar with this problem. First one is search space. What will be the search space? We are talking about the TSP. So all possible permutations of the cities means if I want to reach one city, what are the possible tracks or what are the possible routes? Okay. Fitness landscape. So it should permutate all the distances where the goal is to minimize the distance. Okay. Suppose I want to go for Amirpet. So how many ways I can go for by Ramantapur, I can go via Tarnaka, or I can go from other place. So these are your search space. Then when I'm checking the fitness, what is the total distance traveled? Okay. So what happens? The total distance traveled I'll calculate. So which one is minimum? Finally we'll go for that. Population. So set of possible routes, same thing. What are the routes we are getting and what is the total distance? Finally, genetic operators will use the crossover. In between, you can add two routes. Mutation, you can create one new route within the existing route. So this is your genetic operator, crossover. Okay. So what exactly, whenever you're having any problem, first you have to identify search space, fitness landscape, population, what operator you are going to use. Okay. So same thing, how we are going to do. So what are the steps? Okay. For operators, the basic operators in your genetic algorithm selection, the first purpose is to select from the existing population. And what are the methods for this population, like selection in the population is roll-it wheel selection. So it will select according to their fitness proportion, how much it is fit. I'll calculate the fitness for all the values, which one will have the more fitness value, those values have to be selected. Tournament selection, it will select the best individual from the randomly chosen. I'll randomly choose. I won't calculate any fitness value. Just I'll pick some random values. In that, I'll choose the best. Rank selection, rank individual by fitness and select based on this ranking. So ranking means I'll rank each and every one like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll have the highest rank. I'll select the person accordingly. So first operator is selection. In this, we have three methods: roulette wheel, tournament selection, rank selection. And what is the purpose? Second one is crossover. What is a crossover? Okay, generally it will combine two parents to create an offspring. Okay, so like you're getting new children, okay, or you're combining the properties of two particular things in order to get the new one. And in this, we have methods like single point, 2-point, uniform. So in a single point crossover, so inherit genes from one parent up to this point and from the other parent beyond that. For example, how should I tell you? Okay, so you have the genetic things. I feel that when the baby was born, they don't know anything, but after that, some time extent, they will behave like mother. After that, they will behave behavior like the father. So this is single point. At some point, it will take one genetic from one parent, and after that it will move to the next parent. So this is single point. 2-point is offspring both. Okay, one parent between these 2 points from other parent outside these points. Okay, so it will get from these two parents and it will get from out of the boundary. Like they may get their grandfather or like mother-in-laws, all those things, genetical behaviors. Next one is uniform crossover. Each gene is chosen randomly from one of the parents with equal probability. I won't say that 50% from mother, 20% from father, 30% from grandfather. I'll take equal contribution from all the parents. So this is crossover. Mutation. So in this mutation, what is meant by mutation? Like we will change the existing offspring. Okay, I got one child. Okay, from that particular child, I'll change some of the behaviors. That is called as mutation. So we have 3 times: bit flip, swap, Gaussian. So it will flip value like 0 to 1 or 1 to 0. Okay. So here second one is swap mutation. It will change the position of the two genes. Gaussian, it will add a Gaussian distributed random value to the gene. So first mutation, I can change either 1 to 0 or 0 to 1. Second one, I can swap two positions of that particular genes and I will add some error like Gaussian distributed random value to the existing gene. So this is third one. So what is a generation cycle in genetic algorithms? First one is initialization, evaluation, selection. First, we have to initialize the problem or population of the individual. Then we have to evaluate the fitness of each individual. Then you have to select the individual who will be serving as parent for the next generation because the parent should be having the required fitness, right? Crossover. After getting two pair of parents, we will produce the offspring. If the offspring is according to our requirement, we won't go for the mutation. Otherwise, we have to apply mutation operator in order to the offspring. Replacement. Finally, you have to replace the existing offspring to the muted one. Okay, so this is the last point. Finally, we have to terminate. After getting the required data or required output, so we have to terminate this particular algorithm. Okay. So example, initialization. I want to generate 100 random binary strings. First, I'll check all the binary string using a fitness function. I'll use roulette wheel selection to pick 50 pair of parents, apply the single point crossover to each pair and create 50 new offsprings. If I'm not getting a required 100 binary random binary strings, I'll use bit flip mutation in order to change the offspring. Finally, I'll replace old population with a new place, the new offsprings, and this will be repeated until unless maximum number of generations is reached and an optimal solution is found. So this is the basic generation cycle in the genetic algorithms. Okay, so if you see the diagram, so initialization, fitness evaluation, then selection, crossover, mutation. Okay, if crossover is okay, then I'll directly go for the most fitted solution. Otherwise, I have to go for the replacement. After replacement, I'll check whether these are fitness evaluation. Finally, most fittest solution. So this is the genetic algorithms. So the basic steps we are going to use are these: initialization, evaluation, selection, crossover, mutation, replacement, and termination. Okay, thank you.